are going to be talking about techniques for solving ODEs. So the first technique we're going to be talking about today, this is the first part of our lesson of techniques for solving ODEs. So what we're going to be talking about is separation of variables. There are some ODEs that are separable and there are some that are not separable. What are really ODEs that are separable? Now we have an ODE that is a function of both x and y. Let's say our y prime equals to a function of x and y is an implicit function. We can easily separate some ODEs into something like f of y dy. That means every function of y on one side to be equal to another function of x on another side. So if you can express your ODE in this form, you can easily integrate both sides and get your answer. So we are going to be using these 5 examples to prove our separation of ODE point, separation of variable point. So let's start with the first one. So starting with the first ODE, we have y prime minus 2xy squared equals to 0. So the first step is to bring this to the other side. So we have y prime equals to 2xy squared. Now I can rewrite my y prime. Instead of writing y prime, I can write it as dy dx. dy dx. So what do I do now? I want to separate this. Every function of y on one side, every function of x on another side. So what do? I can easily bring my dx to this side by multiplying through by dx. So if I multiply through by dx, I have dy equals to dx cancel dx on the right, 2xy squared dx. To bring my y away from this side, I divide through by y squared, right? I divide both sides by y squared. So this is going to cancel this, and we have dy over y squared equals to 2x dx. Now, I have functions of y on one side and functions of x on another side. So what do? I integrate both sides to get my y. So I can write this as y minus 2 dy equals to integral of 2x dx. Integrating this, I have y minus 1 over minus 1 equals to 2x squared over 2 plus c. I can simplify this as minus y minus 1 equals to x squared plus c, right? Now, to make y the subject of the formula, I just multiply through by negative, right? I bring this negative to the right side and I have y minus 1 equals to minus x squared minus c, right? Now, but since this is an arbitrary constant, right? I can write my c, my minus c, I can absorb this negative value into it and say plus c. Like, I can easily say this one is c1, this one is c2. But since it's an arbitrary constant, I can just turn it to a plus. You get? I can just turn it into a plus and write this as y minus 1 equals to c minus x squared. Now, to make y the same formula, I bring this negative 1 to the other side and I have y equals to c minus x squared minus 1. How does that work? 1 over y, right? 1 over y is the same thing as y minus 1 equals to c minus x squared. I can now invert it and say y equals to 1 over c minus x squared, which is the same thing as c minus x squared minus 1. So this is the final solution I have. This is the general solution to this ODE using separation method. Going through this step by step, I brought this to the other side for it, right? After bringing it to the other side, I separated the dx and the y. I brought the dy to the one side and the x to the other side. Every function of y to one side and every function of x to another side. So then I integrated both sides. Integrating this one with respect to y and integrating this one with respect to x. So after my integration, I was able to get this and this. Then I simplified and I got my final answer. And I got my final answer. So going on to the next question. So going on to the next question, number 2. We have 2y prime equals to x over y squared. So as easy as multiplying through by y squared. I have 2y prime y squared equals to x. Now I can easily multiply through by dx. We write this as 2 dy dx y squared equals to x. When you multiply through by dx, this is going to leave here and we have dx on this side. So we have functions of y here and we have functions of x here. So I can write this as 2y squared dy equals to x dx. So what do I do next? I have functions of y, I have functions of x, I integrate both sides. So integrating this, I have the integral of 2y squared dy should be equal to the integral of x dx. Integrating this, I have 2y 2 plus 1 over 2 plus 1 equals to x 1 plus 1 over 1 plus 1 plus my constant, my arbitrary constant. So we have 2y cubed over 3 must be equal to x squared over 2 plus c. Now to eliminate these 3 and 2, I multiply 2 by 6. The LCM of 3 and 2 is 6. So I multiply this equation through by 6. So I have 6 dot 2y cubed over 3 should be equal to 6 dot x squared over 2 plus 6c. Now since 6c is also a constant, I can write it as probably, let's say a. Let's say a. A is another constant where a equals to 6c. 3a1, 3a2. 2 by 2 is 4. 4y cubed equals to 2a1, 2a3, 3x squared plus a. So I can leave my final answer like this. Yes, I can leave my final answer like this and say 4y cubed equals to 3x squared plus a plus our constant. And this is the solution. This is the general solution to our ODE that is given here using the separation method. And that's the second question. Let's go into the third. Going to the third question now. So let's go to the third question. For the third question, we have x plus 1 y prime equals to 2y. Now this is a function of x, right? X plus 1 is the whole function of x and 2y is the whole function of y. So what do I do? I just write this first. X plus y dy dx equals to 2y, right? So first thing first, I can divide through by dy, right? Just to take this away. So divide both sides by dy. I have x plus 1 over dx dy over dy. I'm dividing through by dy equals to 2y over dy. This cancels each other out, right? Just to separate them. So I can bring this to my other side now and say 2y over dy equals to x plus 1 over dx. Now since I want to integrate, I have to invert both of them. dy over 2y equals to dx over x plus 1. So I have functions that are now different and they are now integrable. I can integrate both sides quite perfectly now. So dy over 2y, when I integrate this, I get 1 over 2 ln y, right? Equals to ln x plus 1 plus c. 1 over 2 ln y equals to ln x plus 1 plus c. Now, I need my y to be alone. I need my y to be the subject of the formula. So I simplify this equation and say multiply through by 2. If I multiply this side by 2 and this side by 2, I have this cancelled out. Ln y equals to 2 ln x plus 1 plus 2c, right? I can replace 2c with a. Now simplifying this, I have y equals to, I raise both sides to the power of e, which means y equals to e raised to power this. Now I can bring 2 to the other side here. Don't forget the loss of algebra of logarithm loss. E raised to power a ln, let's say ln x, the same thing as bringing this to the other side and saying e raised to power ln x raised to power a. E can cancel out ln and our final answer will be x raised to power a, right? This is logarithm. Now I can bring 2 to this side and say e raised to power ln x plus 1 square, right? Plus a. Now don't forget lots of indices. E raised to power a plus b is same thing as e raised to power a times e raised to power b. So I can easily rewrite this as times e raised to power a, right? Now I can call this e raised to power a my third arbitrary constant and call it c2. Do you understand what I'm saying? So I can call it my third arbitrary constant c2. Then what do I do next? So I simplify this. E raised to power ln can cancel e raised to power ln, right? So my y equals to x plus 1 square times, now c2, we have c2 here. So y equals to c2 x plus 1 square. And this is my final general solution for this particular ODE. And this is the final solution. So that's the third ODE we have solved using the separable equation and separable variable method. Now going to the third one, going to the first one rather. Going to the fourth one, we have y prime equals to 1 plus y over 2 plus x. Now, what do you notice about this? What we notice is that this is a function of y here and another function of x here, right? So I can rewrite this as the y dx equals to 1 plus y over 2 plus x. This is my function of y, this is my function of x. So if I'm to separate this, I'll have cross multiplying 2 plus x dy equals to 1 plus y dx, right? Now I can bring this by dividing. I can bring this under here. So I divide both sides by 2 plus x, 1 plus y. 2 plus x, 1 plus y. So as to separate both variables. Now I have, this is going to cancel out, and I have dy over 1 plus y equals to, this is going to cancel out, and I have dx over 2 plus x. Now I have functions of y on this side and functions of y on this side and functions of x on this side. So the next thing I have to do is to just integrate both sides. Now integrating this one, we have ln 1 plus y, or ln y plus 1 equals to ln x plus 2 plus c, right? Plus c. Now, since I have something like this, I need to make y the subject of the formula. So what do? I raise both to the power of e as we did before. So this cancels out and we have y plus 1 equals to e is also going to cancel out here. But don't forget this. These are arbitrary constants. Don't forget that we can rewrite this clause as times e raised to power c as well. And this is another constant. Don't forget, e is a constant, raised to power another constant is still a constant. So we are going to say e cancels in here too. So we have x plus 2 times our constant. So it means y plus 1 equals to x plus 2. Our constant can come to the front, and we bring this to the other side, and we have y equals to c bracket x plus 2 minus 1. And this is the final solution for our ODE using the separation method. So let's go to the last but not the least question, the fifth. Question number 5. So going to the fifth question, we have 3y squared plus e raised to power y equals to, okay, y prime equals cos x. Now there's something you have to notice here, as always. Everything here is a function of y. Everything here is a function of x. So just write your y prime as the y dx. So you have 3y squared plus e raised to power y dy over dx equals to cos x. So I can basically bring this to the other side by multiplying through by dx and say 3y squared plus e raised to power y dy equals to cos x dx, right? So the next thing I have to do is just to integrate both sides with respect to whatever we have. We integrate this side with respect to y, integrate this side with respect to x. Now when we integrate this with respect to y, we have 3y cubed over 3 plus e raised to power y. When you integrate e raised to power y with respect to y, you still get e raised to power y equals to when you integrate cos x, you get sine x plus c. Yeah, sin x plus c. So this cancels out and we have y cube plus e raised to power y equals to sine x plus c. Now there's something you have to notice here. There is no way you can easily separate this y from this e raised to power. So basically, this is the answer to our ODE. And that brings us to the end of this video. Thank you. Like and subscribe.